topic today is the effective shift left of application security. And I've been in this industry, in security industry, for more than 10 years, and I've been taught routinely that every conference presentation must absolutely start with at least 3 scary cases for the given industry from last year to kind of prime you and scare you properly before we start the subject. But today we are on the event FinCode from home, and I would assume everyone who is here knows why they are there and kind of know why security is important. So instead of doing this, let me start with the provocative question: why do we care for the application security in the first place? And when you think about it, it's never been easier to procure software than it is today. We have software as a service model, prolific. We have almost every type of functionality implemented this way. To give you a background from my own experience at GitLab, where we are a fully remote company, we use around 80 applications, 80 IT services. 79 out of them are software as a service. And when you're dealing with software as a service, it's obviously very little control over the network, especially in remote setting. Very little control over the application stack itself. All you can do is essentially authorization, authentication, and accounting. But that's not the interesting case. For some applications, companies take the decision to build them internally. When you think about the decision factors, it's about cost, long and short term. It's about risks, particularly long term, and the value. And let me argue that particularly for financial sector, these are the applications which are competitive advantage. So if something is built internally, it's built internally for a reason. It's built to represent a process which is unique to the organization, which is the differentiator of that particular company, and provides value to the customers. A friend of mine who is a former CIO of the bank said, we are essentially now a technology company with license for banking. And that's happening more and more, regardless if you are a traditional brick and mortar bank, or if you're insurance, or if you're fintech. The technology is becoming the medium to deliver the services to the customers. But this adds a little bit to the stake at this game, right? Because if the application is a competitive differentiator, this means that it deals with a critical data, it deals with customer experience. It is absolutely critical for reputation of the organization to keep it safe and secure. So with this, very often the discussion quickly gets from do we build the application internally to how we actually going to build it. And popular approach these days is something called cloud native. Why? Because it's quick to start, because it's easy to scale if the application is successful, because it's fairly easy to integrate with other applications. And that's the default way of building the application these days. Now it comes with its own set of challenges, and the critical one of them is the speed at which the modern applications are being built. Contrary to the popular belief, it is not the cloud or the cloud infrastructure, underlying infrastructure, which is typically a problem. A couple of years ago, many organizations considering the cloud were, especially in finance, were evaluating that with a great dose of cautiousness, saying it's a third-party infrastructure, we can't control it. But when you think about it from perspective, the companies like Microsoft, Google, or Amazon of this world, they have scale and budget needed to get best of the best in the industry. They really do have their security process thought through, and a very big stake of failing. Now, it's not a surprise when you think that the typical focus for hackers is not the cloud infrastructure, which is standard. It is the application which is running on it. It's either application itself or its configuration. And there's data to support it, of course, but that creates a different focus from a traditional one. So when you think about modern application, and serverless is an extreme example, it is an application which is composed of multiple microservices exposing functionality via API. And the challenge with API is that you can't really control who's going to consume API and when. You only control if the API is doing what it is supposed to do and how secure it is. And then authentication to the API happens via secrets, and those secrets are managed somehow, probably not in a central way. So how do you prevent hard coding of those secrets in a source code, which might leak eventually one day or another? Also, how do you change and patch in cloud native example, particularly in serverless example? You never patch a running system. You're essentially patching the configuration of that system, which gets recreated from that configuration. So how to make sure that every change is recorded and is there, and it will get recreated in with the right process in the application. Eventually, the biggest challenge of all is that if one monolithic application is now split into 100 microservices, the attack surface is significantly larger for those applications. Every of those microservices is a separate application, which needs securing. The biggest challenge to that is that the traditional way security is done for application is a bolt-on. It's an afterthought. It's like, I have a ready-made product, and now I'm going to secure it. Sometimes it works, sometimes it doesn't. But just to give you the couple hints, flavors of where this can end. Number one, you have an application which is being written, it goes through security assessment, and all of a sudden you find 10,000 vulnerabilities in it. What do you do about it? How do you even assess which of them are real and which of them are false positives? And false positives are here to stay. Every single security scanner will give you false positives every now and then. There are better, there are worse, but false positive is a consequence of laws of physics here. Or another one, if you have traditional way of dealing with security, which is let's slam a web application firewall on top of that, where do you do it? Where's the perimeter if you have 100 microservices talking to each other? So traditionally, this bolt-on approach, it's obviously the consequence of how companies are organized, but it's also a way of dealing with urgency by security departments. If you're working in security and you want to fix the critical vulnerability, you don't want to wait for a month for some developer to make some change in a code in order for this to be secure. You want to pull a knob and make sure that the web application firewall filters that. And there is an opportunity in this because these days, the application cycle is spinning much faster and the changes are introduced much faster. So it's something which can be leveraged essentially. But to do this, we need to change the process and start working in the other way. There is an independent statistic saying that it costs 30 times as much to fix a vulnerability in production as it does to fix it in test development environment. And yet, in our survey, when we ask developers, we get that feedback that 50% of them will say vulnerabilities is something that security detects when we are done with our code. It's not something we can detect on our own. So there is this notion of a wall between security team and development team, which resembles similar thing which happened before for operations and development. It was called DevOps gap, and it kind of got patched. We learned how to do quality as part of the cycle. Now it's about taking security and compliance and making it part of the same cycle, because that's the only efficient way of doing it. There is a law named Conway's Law, which is pretty old, but still holds true. And it essentially says that we model the systems we build after the existing communication. So if the organization is structured in a given way, the systems will be structured in the very same way the organization is structured, because that's how people procure, build, and integrate systems. But that creates an opportunity, which is called inverse Conway maneuver, which says if you want to break that silo, start with the technology, start with the application, which is like a communication bridge for people to start communicating differently. And they will do that because inherently people are interested in their success and the success of their organization. They are bound by the constraints, but they want good things to happen. And that happened before for DevOps. You can't do DevOps properly without something which was called DevOps toolchain, and we in GitLab argue that toolchain is too much. You need just one tool for efficient communication. But tool is the medium for communication. You can have people with best intentions. If they do not have a way to communicate at scale, solving the problem, they will not do it. That's a big challenge about DevOps, that technology and process are so interleaved, and that's the same thing for security here. So to make it more specific, traditional way of scanning the code is, especially for running penetration test, dynamic application security testing. So the script which is executing different type of exploits against the running application and checking if the application is actually vulnerable or not as the final stage, and it's really needed to see not only just the code, but how the application really behaves when installed. Traditionally, this has been limited by the availability of the environment in which the application should be installed. So if you think how the development process looks like, the whole power of Agile comes from the fact that people are working in parallel. They don't block each other. Regardless if this is Kanban or if this is Scrum, people have a pool, certain backlog of work. They pick from it, they do their stuff, they commit to the main branch of the repository, and then they pick another work item. And because they can do it in parallel, it's efficient. Now, this does not apply to the security scanning, because the security scanning needs an environment, and very few organizations can afford a fully fledged environment of the application per every developer, so that these tests can be executed. And what we propose is fairly unique to us, because we not only control with GitLab the code and the features and the continuous integration, the way to test and build, but also the environments. We provision environments. We have very tight integration with Kubernetes. So when the application is being built, we can provide a transient environment called review app and execute all the tests in there. This review app can also be available to the developer to see what he has done or she has done. And all of this happens prior to merge. Why is this important? The very moment the developer code goes to the main branch, to the master, it is, if the code is bad, we have contaminated the master. The old Agile principle says that you should always keep the master green. It should always be releasable. It should always be in a good state. Now, if it is quality-wise in a good state, but it's not secure to release it, it's not green. So contaminating the master is something we can prevent by running all the tests upfront. But there's also a psychological effect on the developer. Engineers hate doing the work and thinking it's done, and then get it back after 3 weeks saying, by the way, you need to fix this and that. Nobody likes fixing bugs in the first place, but fixing bugs which were committed 3 weeks ago is a pain, because you simply don't remember what have you done 3 weeks ago. And now it's all about switching mental context and going back into something under pressure of time, because the release is due and it's under threat of being delayed. And I'm not advocating here by any means of not doing formal security review at the end of this process. It's actually quite contrary. What I'm saying is, the more we shift left and give the power to the developer to do their job, the less we stress security team, the less risk of delay of the application, and the more common joint responsibility for security posture happens. Developers actually getting the tools, they start feeling responsible for the outcome of their work, and help scale security team, essentially become security advocates in the engineering community, which is a very interesting cultural perspective to consider. So now, so far so good. That's the process. What about the contents of this process? And there is this old goat wisdom that if the door is super secure and locked, there is always an easier way to get in or out. And for this reason, it is important to look at the actual full risk profile of the application. What do we scan? When do we scan? And what are the tangible risks resulting of it? Typical approach, and also, in my opinion, a typical omission, is to look at the source code only. If the source code is free of the obvious bugs, that's great, but maybe not so, because when you look at the statistics, this one was actually executed by our friends at Black Duck, I believe. They do manufacture their own scanner, and that's an enterprise grade scanner. So they checked on the code base of their customers, and in 2017, 57% of the code base was open source libraries integrated into those enterprise applications, up from 36% the year before. So that's a majority of the code which is running there is actually not owned by the enterprise who's using it. That's the only way to speed up and scale at the necessary pace. But at the same time, the drawback of using open source code is that no one is going to send you an advisory saying, hey, by the way, you're using vulnerable version of our library, please change. The information is there on the internet. Everybody's free to see it, but you need to have a process in order to do it on time, to patch on time in the other way. And those dependencies, those 57% is just the source code. It does not even include the base Docker images and software installed in the base Docker images, which is potentially in use. So having a right dependency scan is equally important, maybe even more important than testing your own code. And in the end, the dynamic application security testing, so the penetration test executed against a live application, is the only way to finally verify that that the application is secure. And having it in a process means that every single time something happens or there is a new potential vulnerability, you can add it to the scanner and execute every single time. So it's actually building the quality and security into the process. Finally, once you have that process, that's also an opportunity for license compliance. How do you make sure that you don't get a viral open source license which can force you to open source the whole project just because you integrated it at certain point in time? But what I'm advocating here really is making sure that you have the tight process before you have tight tools in place. Why is that? Because the tight process is harder to figure out later on. tools can change. We are providing an open interface to integrate with third-party scanners. First integrations are starting to pop up now. Essentially, this is something you could even do in-house. It's all about packaging the scanner in a Docker image and making sure it emits its output as a JSON which GitLab can understand. And you can plug in any scanner into this framework. But first, you need a framework to plug it in. So that may be the more important takeaway here. So what actually happens, how it actually works? Well, first of all, the very moment merge happens, there is a group of people, likely developer and some of his peers from multiple groups, who are supposed to look at the merge request before the code gets actually merged to master. And they need information because they need to make an informed decision quickly. So all of the output of the scanners, the SAS, the DAST, the dependency scanners is provided here in one place where they can see what is the amount of vulnerabilities, what is the amount of new vulnerabilities related to the change, what is the actual risk consequence of doing this, and they can take decision. There are multiple ways to deal with that. You might want to have a security personnel being part of that review, or you might want to delegate that responsibility to the developers at this stage, shifting from the preventative type of control to detective type of control. It all depends on the particular requirements of the application. But important thing is that people who take this decision have all the information in one place. And they can drill in. They can see the details down to the particular line of code which was detected by the scanner and make their own judgment. When they do this judgment, they essentially have three ways of dealing with this situation. Way number one, it's a quick fix. It's something which can be done in place. The application can be rebuilt and retested. That's the ideal situation. So we fix it and we go on. Number two, the work can be so serious or the consequences so serious that we actually need to stop development. Good news, it's still pre-merge. So if we stop development, nothing is changing on a master. But eventually, it might be that we want to merge it, but we want to record a unit of work to deal with that later on. And here, clicking with just one button, create issue, you create a work item, you put it back into the queue. For some cases, the remediation, the first scenario where you can fix things in place can be even automated. Well, looking at how reality looks like, no developer likes fixing bugs, and no developer particularly likes fixing security bugs because it doesn't give him or her any recognition. So if this is something simple, like just we know that there is a vulnerable version of the library included in the dependencies, and we know that there exists a non-vulnerable version of the same library. Why not automate downloading the newer version, retesting the application from the unit and integration perspective, and seeing if the application still works? If it still works, then there is no functional consequence of downloading the newer version, and it can be automated end to end. If there is consequence, you can always reverse and say, this is something we'll focus on later. From the organizational perspective, especially that you delegate this decision to developers, there is a very important visibility factor. For security personnel, every shifting from preventative to detective control is always uncomfortable. What's gonna happen? What do these developers do? Do they know how to determine critical vulnerability from non-critical vulnerability? Well, there is again, increasing visibility is a way to go. Here is the dashboard which shows the security profile for the whole group of projects, and it allows security to drill into every single case, including differentiating between the dismissed vulnerabilities, so the vulnerabilities that someone at the merge time decided it's not critical, gave their comment, and that vulnerability disappears from the merge request from now on. But here, the security person in the upper right corner can click disable hide dismissed and go into details and decide if this is something which was rightfully dismissed or maybe not. So now, critical thing in this, and the only reference point I'm going to show today is the adoption. Because if you want this to work, you need developer help. You need to work with developers on building that culture together. And my favorite example is from our friends at Goldman Sachs, who, after moving from a tool chain which was built from multiple different tools, required high ramp up and was brittle, they moved to single application that GitLab provides. 1,500 developers adopted it voluntarily. There was no pressure put on them in 2 weeks and started working in that new tool chain. This is critical for this whole change to be effective, because if you have great tool, and that is true that the same effect can be achieved with any tool at certain cost, but if people won't use it, there won't be any benefit from that. And I think that is something I'd like to leave you with by the end of this presentation. Also, in many organizations, GitLab is already used because we are open core, so it's easy to adopt GitLab. Those security-related features are not there. They are part of the Ultimate License and Enterprise Edition. But the good news is that functionally, there is no difference between running Enterprise and Community Editions without license. These are the same thing. So if you are interested in testing those functionalities, it's all about applying the trial license, and those scanners will automatically pop up there and become available to you.